Hello everyone. In today's session, let us discuss about SR latch. So what is meant by SR latch? Latches are digital circuits that store a single bit of information and holds its value until it is updated by new input signals. They are used in digital systems as a temporary storage element to store binary information. Latches are level-sensitive devices. Latches are useful for the design of asynchronous sequential circuits. Latches are sequential circuits with two stable states. There are different types of latches available: SR latch, JK latch, T and D. So in today's session, we are going to discuss about SR latch. Latches are and when where it is being used. It is widely used in digital systems where data storage is necessary, that is memories, control circuits, and flip-flops. For flip-flops, latches are the major component. They are often used in combination with other logic circuits to implement sequential circuits such as state machines and memory elements. And this is the symbol of SR latch. If you see an SR latch, it has two inputs, S and R, and two outputs, Q and Q dash. This is the circuit diagram of SR latch with NOR gate. SR latch can be realized using NOR gate as well as NAND gate. This is the circuit diagram of SR latch with NOR gate. And if you see the circuit diagram, you can see two NOR gates which are cross-coupled to each other. So cross-coupled in the sense, here we have two NAND gates. Let me name this as NAND 1 and this is NAND 2. For NAND 1, the input will be R, and for NAND 2, the input will be S. So this is a NAND gate. It requires two inputs. So one will be R and S, and the other input for the NOR gates will be Q and Q dash cross coupled with each other. So it has two inputs, two outputs. And let us now discuss how this SR latch with NOR gate works. When we give S is equal to 0 and R is equal to 1, when we give S is equal to 0 here and R is equal to 1, and let us assume that Q and Q dash has certain values. Assume some previous values, stored values will be there. Assuming we will get Q is equal to 0 and Q dash is equal to 1. When I change the inputs, that is when I do not give inputs, or when I give the inputs, S is equal to 0 and R is equal to 0, see immediately S is equal to 0 and R is equal to 0, we will get the same outputs as when we give S is equal to 0 and R is equal to 1. So this table shows that when S equal to 0 and R is equal to 1, Q is equal to 0 and Q dash is equal to 1. Then when we give S is equal to 0 and R is equal to 0, again Q will be equal to 0 and Q dash will be equal to 1. So see, when the inputs are given as 0, 0, it maintains the previous state. So no change. So this state, when S is equal to 0 and R is equal to 0 for an SR latch, we call that state as a memory state or no change state, or the previous state will be retained. Let us consider the next case when S is equal to 1 and R is equal to 0. That is, here we give 1 and here we give 0. In that case, see, from the truth table of NOR gate, if we check, we will get Q is equal to 1 and Q dash is equal to 0. So then again, when I change S is equal to 0, now see the outputs has been changed from 0 to 1 into 1 to 0. So now when I give S is equal to 0 and R is equal to 0, the same previous state is being maintained. So from this, we can infer that whenever we give S is equal to 0 and R is equal to 0, the previous state will be maintained. And next, since we have two inputs, we'll be having four different combinations. So the fourth combination is S equal to 1 and R is equal to 1. And obviously here, if you see the outputs of SR latch, see this is Q and this is Q dash. That is, if this is Q, the other output will be the complement of that. But if we give S is equal to 1 and R is equal to 1, see the outputs Q is equal to 0 and Q dash will be equal to 0. That is when we give 1, 1 here, and these two inputs will be the previous, that is Q. In the previous state we have Q is equal to 1 and Q dash is equal to 0. So this 1 will be going here and this 0 will be going here, right? So what happens is both the states will be either having 0 0 or 1 1, which becomes an invalid state. So this is the truth table for SR latch. That is, when S is equal to 0 and R is equal to 0, it is a memory state. That is, no change will be there. That is, the previous state will be retained. When S is equal to 0 and R is equal to 1, the outputs will be 0 and 1. When S is equal to 1 and R is equal to 0, the outputs will be 1 and the complement will be 0. When both the inputs are 1, the outputs is invalid. And this is with NAND gate. So in the previous case, we have seen SR latch with NOR gate. This is SR latch with NAND gate. Here we have a slight difference in the circuit. When we consider SR latch with NOR gate, here we have given for the NOR 1, we have given R, and here for the second NOR, we have given S. In the case of NAND gate, here we will give S and here we will give R. So see, the outputs, the outputs also will be interchanged. When you give S is equal to 0, R is equal to 1, the outputs will be 1 and 0. And now when S is equal to 1 and R is equal to 1, the previous state will be maintained. So just the inverse when NOR gate has been used. Then when the third condition is S is equal to 0 and S is equal to 1 and R is equal to 0, Q will be equal to 0 and Q dash will be equal to 1. So we'll be giving this to this circuit, 0 and 1. So in this case also, again, if I change the S is equal to R is equal to 1, the previous state will be maintained. And the last case is when S and R are equal to 0. When S and R are equal to 0, it goes to the invalid state. That is, both Q and Q dash will be equal to 1, which is not acceptable. And so this is the truth table. So see, when we realize an SR latch with a NOR gate, the unstable state, we receive the unstable state when S and R are equal to 1. When we realize using NAND gates, we will have the unstable state when S and R are is equal to 0. Right? In both the cases, so we have the unstable states or invalid state or undefined state. Now this is for your assessment. What is the purpose of SR latches set reset latch in digital electronics? What are the applications? In an SR latch, what is the state when both set and reset S and R inputs are asserted simultaneously? This is for your thought, and thank you.